Hello and welcome to another video on wired and wireless networks. This is the second in the series, and today we're going to be looking at network performance. So really it's all about learning about the key factors that influence network performance, being able to describe these factors, compare and contrast them as necessary. Network performance is concerned with how well data is transmitted through the network. The main factors that influence network performance that we should be able to talk about are the bandwidth of the network, the number of users, the transmission media used, error rate, and latency. And we're just going to go through these briefly one at a time so that you can describe this in your exam. So if we start with bandwidth, bandwidth measures how much data can be transferred over a network in a given time. Although it is often used interchangeably with speed, bandwidth refers to capacity, not speed. They're slightly different. Think about bandwidth as the size of the internet pipe that you're using, not the speed of the data passing along it. Think about a road. Bandwidth would measure how many cars can travel down the road at one time, not how fast those cars are going. Bandwidth is measured in bits per second, sometimes shortened to bitrate. You've got kilobits per second, which measures thousands of bits per second. You've got your megabits, which measures millions of bits per second, and your gigabits, measuring billions of bits per second. Be careful here. Remember that there are 8 bits in a byte, so that a connection of 8 megabits only delivers 1 megabyte of data per second. Often companies like ISPs that we use to connect to the internet advertise speeds that seem a lot bigger on their advertisements than they do in real life. And that's because their advertised speeds are using bits per second, not bytes per second. So for example, an internet connection that offers 40 megabits isn't actually going to give you 40 megabytes of data every second. It's only going to deliver 1/8 of that. So that's going to be 5 megabytes. Okay? So again, with network transmission, we're measuring in megabits, not megabytes. So that's 1/8 of what we might necessarily think they're talking about. All right, so let's look at the number of users. As we know, networks support many users. The bandwidth of the network is shared between all the people on the network. However, it is not always shared equally. So the idea is if you're sharing a network connection with somebody who's streaming an HD video, maybe even a 4K video, they're going to be using a large chunk of the bandwidth, using less for others. Okay? So again, this bandwidth is shared between all the different users of that network, but depending on what different people are doing, they might take up a greater or lesser share of that bandwidth. Transmission media. What we call transmissions or communications media is what is used to transmit the data through. Think about it like it's the physical medium that we're using to send those ones and zeros down. So data can be carried around networks via cables or wirelessly. And the choice of what media we're using can affect the performance of the network. Copper cables are often used for the Ethernet cables on LANs. There are different types of cable, and the more expensive cables can carry data at expensive speed. So that is a little typo there. Apologies for that. So different qualities of cable can carry data at different rates. More expensive cables can carry more data around. Less expensive cables can carry less data. In some countries, we use old copper telephone cables to connect WANs together, wide area networks. However, using copper cable like this for a wide area network isn't a very good idea. These are designed for voice telephone calls. They have very limited bandwidth when it comes to sending and receiving internet data. Nowadays, for connecting wide area networks, we're really hoping to use fiber optics. So fiber optics look a lot more modern, a lot more cool, and that's because they're going to be transmitting light down them, and that's going to allow for a much greater bandwidth compared to the older copper cables. However, fiber optic connections are a little bit more expensive, especially if you have to dig up all the old copper cables and replace it with fiber. We can also use wireless technology, Wi-Fi, to transmit data over a local area network. So this is how a lot of us will connect to the internet in our homes or offices. There'll be a wireless access point or a wireless router somewhere, and then we can just connect using radio waves to it from all our different devices. This avoids the need to install cables and make alterations to buildings. You don't have to dig any holes in walls or anything like that. And it allows easy connections of new devices. This is especially useful when visitors to an organization need to connect their portable devices to the organization's LAN or the internet. So again, I can go to my school, I can connect my laptop to the school's Wi-Fi network. I don't need an Ethernet cable. I don't need to worry about that. It's just easy to add and remove it from their network when I need to. However, Wi-Fi has less of a bandwidth than Ethernet cables. This can be a big problem if many users are sharing the same bandwidth. And I'm sure you've experienced that. Lots of people are using their devices at the same time. This is really going to cut into the bandwidth that's available. Wi-Fi performance can also be affected by signal interference, the thickness of walls, etc. So Wi-Fi connections aren't as reliable as wired connections. You also have this potential problem of security. Wireless signals can be intercepted very easily, so protective measures are needed to ensure that our network traffic is secure. So you have to kind of encrypt the data from one side to the other to make sure anybody who's picking up on those data packets that are flying through the air can't actually read the data that they're intercepting. I think I probably mentioned in a previous video, Wi-Fi can have a range of several hundred meters, so somebody can be outside of the building and can try and eavesdrop on the Wi-Fi traffic, so encryption is a must for a Wi-Fi connection. However, with a wired connection, it's a bit more secured automatically because you actually need to physically connect to the cable in order to try and monitor the traffic. Error rate. The number of errors that occur during data transmission. So the idea is that a 1 flips and becomes a 0 or vice versa during the transmission of the data. And this can happen for a variety of reasons. You can have interference, you can have weak signals, but obviously once we start introducing errors, we're going to slow down the performance of a network because that data has to be checked and resent again and again until we get it right. Latency, the latency monster. Latency is a measure of how much time it takes for a packet of data to travel across the network. So at the start of the video, we're talking about bandwidth, and people often think bandwidth equals speed, but really latency measures the speed of the network. It's basically how long it takes the data to get from one side to the other across a network. So this is not normally a problem on local area network, as all the nodes are close together. But this is a bigger problem on wide area networks, especially the greatest wide area network, the internet. Every cable, every switch, every router on the network adds a delay, latency, to the connection. And if you've ever done any online gaming, you've experienced latency. If you have a large amount of latency on the network connection that you're using, it's just difficult to control your character. It's difficult to take part in the game because of this huge delay between you making an action and it being transferred to your character on screen, and then across the network to everybody else. So if you're an online gamer, latency is the big enemy. You want to minimize how long it takes for those ones and zeros to get from one end to the other of the network. Alright guys, we'll finish off there today. So now we should be able to describe different factors which affect network performance, particularly the bandwidth, the number of users, the transmission media, the error rate, and the latency. So good luck with your studies, and I'll see you in the next video.